morning. I am Dr. Muthukumar. I am here to present this class notes on internal combustion engines. The topic I am going to take today is the comparison between the 4-stroke and 4-stroke petrol engine and 4-stroke diesel engine. First of all, we will see what is a petrol engine. The classification of petrol engines are 2-stroke cycle petrol engines and 4-stroke cycle petrol engines based upon number of cycles and the fuel being used as diesel or petrol. This is the normal cycle of a petrol engine operating on a 2-stroke cycle. You can see the working of the 2-stroke cycle petrol engine with 2 ports, input of the fuel from the inlet port and outlet through the exhaust port. The top of the cylinder we can see the combustion taking place with the spark plug and color red changes to indicate that combustion is taking place. Through the transfer port onto the left and onto the right here, the charge is recirculated in the crankcase and finally getting exhausted into the atmosphere. This construction of this 2-stroke engine is going to be dealt here. So when we talk about the construction of the 2-stroke engine, a piston reciprocates and the piston is connected to the crankshaft by means of connecting rod. In the case of 2-stroke petrol engine, there is no valve. In the place of valves, we are having ports. Ports are nothing but openings. So it can be inlet port, exhaust port and transfer port. And we have seen in the previous slide, all these are existing on the sides of the cylinder. The opening and closing is automatically happening. Crown of the piston is the top of the piston. The top of the piston will be having a concave shape, so such as it can make a swirling of the gas on the top of the cylinder. A spark plug is a must for a petrol engine, whether it is 2-stroke or 4-stroke. We have seen that the piston top there is a spark igniting the fuel. Okay. So further going to see piston moving from bottom dead center to top dead center. This is the top dead center and the bottommost position is called the bottom dead center. The distance it is moving is swept volume. Swept volume is the total volume covered by the piston. During this process, naturally the pressure and temperature increases. Increase in pressure only causes the compression. The picture here refers to the 4 stages of working called as strokes: power stroke, exhaust stroke, intake stroke and compression stroke. During the power stroke, both the valves are closed in a 4-stroke engine. When the power is produced from the fuel and downward stroke is initiated. During the next exhaust stroke, the piston is moving upward. Because of this, there will be expelling of the burned gases, so outlet valve has to be closed, has to be open, and inlet valve has to be closed. This completes one complete revolution of the crankcase. Next, during the next downward movement of the piston, inlet valve is timed to open. During this time, the pulling of air takes place inside, that is charge. From the carburetor, a fresh charge is introduced into the top of the cylinder. So this is 1.5 revolution. Again, both the valves get closed when the piston is moving upward. Compression takes place. This is the time when we have to ignite the fuel. When the piston has almost reached to the top of the cylinder, the compression is very ready to create the combustion process effective. So this animation shows the different process in the 4 strokes. The next animation, here we can see the charge and expelling. You can actually see a rocker arm. Rocker arm here means further, sir. Okay, further you can see both these animations in a combined slide. The compression ratio is going to affect the petrol engine, but not in a great level, because the compression is only up to 8. Whereas in a diesel engine, the compression is achieved many more times. Only because of the compression, the combustion takes place in a diesel engine. Compared to the atmospheric pressure, it is about 6 to 12 times compression pressure is created in the combustion chamber. Temperature also is created, and compared to the normal room temperature, about 10 to 15 times higher temperature is created. So these are all making the operation of a IC engine based upon petrol engine very effective and feasible in day-to-day conditions. When we observe the 4-stroke diesel engine, similar kind of setup can be seen. The only difference what we can see is, in the place of the spark plug there is a combustion zone with higher compression rate is created, and in place of the carburation a fuel injector is created. Further we can see the construction is very rigid, and there is no particular changes other than there is a side wall with the provision called water jacket, because the heat developed during the process of the diesel engines is very huge. Whereas in the case of petrol engine, we are provided mostly with the fins, which are called extended surfaces. So both the type of engine, diesel engine as well as petrol engine operating on the 4-stroke, they are having 2 complete revolutions during the 4 strokes, and they are much productive than the 2-stroke engines. So further we can see what is used as a fuel that is going to decide the name of the engine, rather than what is the fuel alone is doing. When we see this series of events in case of suction stroke, as the first item in the operation, the piston is moving again from the top dead center to bottom dead center. We can take either the working stroke or the power stroke as the starting of the cycle, or the suction stroke. Technically we can take the power stroke because that is going to be the initiation of the power. Suppose we take the suction stroke as the first stroke. Again the same kind of operations is going to be repeated. So I have taken deliberately to discuss the working of the 4-stroke engine based upon the suction stroke as the first stroke. After that, compression stroke will be followed, whereas the compression of the charges taking place. There is no spark plug here, so compression should ignite at one point the charge, and it is self-tuned to an extent that whenever the maximum compression is reached, the charge is automatically ignited. In the case of the third stroke, the working stroke, the expansion has to be followed, but first of all the cylinder movement for the piston is the downward movement. During the process of burning, before we get the exhaust, we should get to know about the term called scavenging. Some of the animals are called scavengers because they expel out the waste from the atmosphere or from the neighborhood. Here the meaning of the scavenging is removal of the unwanted burnt out gases. This is to do two purposes. One is to admit the fresh charge, and the second one is to clean out the engine to be ready for the subsequent operation. So this action takes place in the two-stroke engine also. The scavenging is automatically happening. The scavenging process, when we discuss in detail, what happens in the during intake of the fuel is a highly capable charge which can burn, but fresh charge, when it is burnt, has to enter again. So the same area used to be occupied again for the fresh charge. As we discussed, that ports are open here in case of two-stroke engine. During the scavenging process, both the transfer port and exhaust port are kept open due to the natural movement of the piston inside the cylinder. There is a possibility that fresh charge is escaping through the burnt out gases because there is a mixture of the two actions here. While the inlet of the charge is taking place, exhaust is also simultaneously overlapping. This is inevitable, and due to the design of this two-stroke engine, we are creating it. You have to mind this, that only two strokes are possible within a complete cycle, and these two strokes have to be repeated again by burning a fresh charge in the next cycle. That is, one complete revolution is only having two strokes. Deflected shape here plays a very important role in the scavenging because an angled manner of pushing the gases through the outlet port or the exhaust port causes the expelling of the gases. So the process is generally known to be scavenging when you are putting out emission into the atmosphere through the exhaust port. Further, we will consider comparison of these two. What we have observed, the differences in the pressure is more in case of compression ignition engine. Temperature is also more in case of the compression ignition engine, which is operated with diesel. Because it draws air into the cylinder only during the suction stroke, these four-stroke engines are compared here in the point number 4. Burning of fuel takes place at constant volume in case of SI engine. Burning of fuel takes place at constant pressure. That is another difference. Electric spark aided by the spark plug is in spark ignition engine, whereas ignition of fuel takes place by the hot compressed air. The quality of the engine, when we compare, governed engine means they can be put into a safe range of RPM. The speed of the engine is controlled by varying the quality of the air fuel mixture in the case of compression ignition engine. The throttle valve can be very easily controlled by a setup called the governor in case of petrol engine. Petrol engines For the applications, widely they are used in the automobiles, right from the mopeds to heavy vehicles. But they are very costly when we go for the heavy vehicles. Diesel engines are very much suitable for heavy vehicles because they can produce much more power than the power produced by the equal capacity of the petrol vehicles. Quickly, we'll see the merits and demerits here. It cannot say that speed range is the merit, but operation wise less and less wear and tear is created in case of the spark ignition engine, whereas the compression ignition requires more servicing and caretaking, but it is very efficient in case of load capacity. People will prefer petrol engine for the easy starting as well as less maintenance. So when the vehicle is a light kind, people will prefer the petrol vehicle. When it is used for heavy duty operation, obviously compression ignition based diesel engine are preferable. The cost is also a comparative figure here. As we discussed, cost and maintenance are very less in the case of spark ignition engine. The noise they produce as a pollution is also very less. Almost you can see the pleasure vehicles are made of the petrol engines, whereas heavy duty vehicles are made to run with the diesel as a fuel, as a compression ignition engine. Thermal efficiency is also to be compared here, is less in case of the spark ignition engine. That's why they produce a light effort, whereas thermal efficiency is very high because of the compression ratio is from 12 to 18. To highlight the one more difference, the lighter construction of the engines called the spark ignition engines for the same power when compared to the higher capacity of the 4-stroke engine of diesel kind is very useful in the day-to-day operations. You can further write that the design of the ports is very simple in case of 2-stroke engine. The design of the valve mechanism is very difficult, and 4-stroke engines obviously going for many maintenance cycles during the lifetime. Initial cost is very more. Cannot see many engines fitted with the 2-stroke diesel because operation wise they are less efficient. Air cooling and water cooling is already discussed. If you have any other discussion here, it's only again and again highlighted 2-stroke and 4-stroke. Any queries? You can mail me at muthukumar@weltechmelitech.org. Thank you for participating. Any queries? You can feel free to drop me a mail. To revise the content from the beginning, Thank you.